Hello, and welcome to Lab 1, Part A2, Longitude, Latitude, and Miles. Measuring distance. In this section of your lab, your goal is to calculate the distance in arc minutes, nautical miles, and statute miles between two locations. The locations described in your lab are as follows. You'll calculate the distance between Quito, Ecuador, and Nairobi, Kenya, as measured along the equator at 0 degrees north-south latitude. Also, you'll measure the distance between Barrow, Alaska, and Hammerfest, Norway. This measurement will be along 70 degrees north in latitude. It's important to note that these major cities do not fall exactly on the 0 degrees north-south equator or the 70 degrees north latitude line. However, to simplify this exercise, we will assume that they do. To begin, in Google Earth, turn on layer Part A2 by selecting the checkbox and expanding the layer. Additionally, turn off layer Part A1 by unchecking the box. Next, you'll obtain coordinates in longitude only for each of the 4 locations. First, double-click the A1 Quito, Ecuador layer. Google Earth will zoom to this location, and a pin drop will mark its location. Next, right-click the pin, select Properties, and find the coordinates shown in the pop-up window. You will enter each longitude in Table 4 of your lab assignment. Make sure to only include degrees and minutes with no seconds in your answer. Also, remember to include the cardinal direction. Pause your video and complete the table in your lab assignment for this section now. Next, you'll practice calculating distance between 2 example locations. To better understand your lab assignment, we'll walk through the conversions and calculations used to determine the total distance between these 2 locations. Notice in this example that both locations are on the same latitude of 30 degrees north. Thus, the distance between the locations equals the difference between those 2 positions in longitude. The longitude at each location is provided in degrees and minutes. So let's begin by calculating the distance in arc minutes. In this example, you'll learn how to add together 2 coordinates of longitude listed in degree minutes and convert into arc minutes for a total distance between locations. To measure east-west distance in arc minutes between these 2 example locations, we'll need to begin by converting the degrees portion of the longitude into arc minutes. First, add together the degrees of each location as seen here in the table. By adding degrees, it gives you the total number of degrees between the 2 locations, or 100 degrees. Next, convert 100 degrees into arc minutes by using the conversion of 60 minutes per 1 degree. This gives the total distance of arc minutes per degree of 6,000 minutes. Now we need to circle back to the original coordinates and add together the remaining arc minutes, which equals 34 minutes. Thus, finally, we can add together your calculated arc minutes, and this will equal the total east-west distance between the 2 locations, or 6,034 minutes. Using these calculations and conversions, refer to your lab assignment and complete the table using your original locations. Pause the video now and complete the table. Next, we will use our previous example to practice converting arc minutes into nautical miles. Start with the converted arc minutes calculated from the previous example of 6,034 minutes. At this point, you'll need to recall that lines of longitude are not parallel, but converge at the poles. Thus, the physical distances between lines change. At the equator, the distance ratio is 1 minute to 1 nautical mile. However, as the lines of longitude converge towards the poles, the distances decrease. Thus, the ratios decrease. Our problem distance question asks that we measure along the latitude of 30 degrees north. Table 1 provided in your lab lists the physical distances represented by a degree and minute of longitude at different latitudes. By using this table, we can see that at 30 degrees latitude, the ratio is 1 minute per 0.866 nautical miles. Thus, we can use this ratio to convert 6,034 minutes into 5,225 nautical miles. Using these calculations and conversions, refer to your lab assignment and complete the table using your original locations. Make sure to show all your work and all appropriate units. Pause the video and complete the table now. Next, we will practice converting nautical miles to statute or standard miles. We'll begin by using the nautical miles computed in the previous example of 5,225 nautical miles. The ratio for this conversion is 1 nautical mile per 1.15 statute miles. Since our nautical miles were already converted for the distance measurement between lines of longitude, we can use the ratio directly to convert 5,225 nautical miles to 6,009 statute miles. Using these calculations and conversions, refer to your lab assignment and complete the table using your original locations. Make sure to show all your work in all proper units, pause your video, and complete the table now. The last calculations for this section ask for the distances measured from the equator to the latitudes of your original locations. To do this, you must now think north-south. Use the examples listed in the table to help you with your calculations to convert degrees to arc minutes to nautical miles, and nautical miles to statute miles. Conversions in latitude are a bit more straightforward because the distance between lines of latitude does not change. Thus, you can use the 1 arc minute to 1 nautical mile or 1 nautical mile to 1.15 statute mile conversions as seen in the table. It's now time to complete your lab assignment for Part A2, Longitude, Latitude, and Miles. Then watch Video 5, Part A3, Map Projection Distortion. Please address your questions to your lab TA.